two types of conditional statements. We have if and else and switch and case. You're going to learn about if and else in this lecture, and we'll look at switch and case in the next lecture. So imagine in our application, we're going to get the current hour, and depending on its value, we're going to greet the user with a different message. So if the hour is between, let's say 6 a.m. and 12 p.m., we're going to display something like good morning. Similarly, if it is between 12 p.m. and 6 p.m., we're going to display good afternoon. Otherwise, we're going to display good evening. So we want to have some logic like this in our application. That's where we use if and else. So we start with if, then we add parentheses, and in between these parentheses, we add a condition. If this condition evaluates to true, the statement that we put after will be executed. Now, if we have multiple statements, we need to put them in between these curly braces. We refer to these as a block of code, okay? Now, optionally, we can have another condition. So we write else if, once again, parentheses, another condition. Now, if this condition is true, then this other statement will be executed. And similarly, if we have multiple statements, we need to surround them with curly braces, like this. Also note that, as a convention, when we want to define a block of code, we put the first curly brace on the same line, not here. That's kind of ugly in JavaScript. So take that into account. Now back to our if and else, we could have yet another condition like this, yet another condition. We can have as many conditions as we want. There is no limitation. And once again, here we can have one or more statements. Now, optionally, if none of these conditions evaluate to true, we can use else to execute one or more other statements. So this is the basic structure. Now, we want to get this logic and map it into this structure. It's very easy. So let's start with our first condition. If hour is between 6 a.m. and 12 p.m., so that's the condition, and the statement we want to execute is good morning, okay? So I'm going to declare a variable here, hour, and set it to 10. Now in a real-world application, we want to read the current hour. For now, let's not worry about getting the current time and just hard code this number here, 10, okay? So we want to compare the value of hour with these two numbers. Now for simplicity, let's go with 24-hour time format. So we want to see if hour is greater than or equal to 6 and hour is less than 12. You learned this in the last section, right? So here we're using these comparison operators. We have two expressions. Here's the first one, here's the second one, and we're applying the logical AND in between them. So if both these expressions evaluate to true, then the result of this expression will also be true. Now let's add the statement. We want to display good morning. And of course, we need to terminate this statement with a semicolon. Now here's my suggestion for you. If you want to master JavaScript, pause the video now and continue implementing this logic using if and else. Then come back, continue watching, and see my solution. All right, let's continue. Here's the second condition. We want to check to see if hour is between 12 and 18. So very easy. If hour is greater than or equal to 12 and it's less than 18, we want to display good afternoon. So console.log good afternoon. Now in this example, we don't need this other else if because otherwise we want to display good evening. So let's delete this. Otherwise we do a console.log of good evening. Now in this example, because we're dealing with a single statement, these curly braces are getting in the way and creating noise in the code. So it's better to get rid of them and simplify the code. Here's another pair. Okay, that's better. Now save the changes. We get good morning here. If I change the hour to 13, we get good afternoon. And if I change this to 20, we get good evening. So this is all about if and else. In the next lecture, you're going to learn about switch and case. All right, now let's take a look at switch and case. So let's start by declaring a variable called role. Let's imagine this represents the role of the current user. Now we want to see if this user is a guest or a moderator or an admin. We can easily implement this logic using a bunch of if and else statements. But there is another way, using switch and case. So let's have a look. We start with this switch statement. We add parentheses, but instead of adding a condition here, we add a variable. In this case, we're going to add the role variable. Now we add curly braces. Then we add one or more case statements. Each case statement is used to compare the value of this variable with something. So here's our first case. If this role equals guest, so I'm comparing the value of role with guest. Now we add colon, and then after that we add one or more statements. So we can do a console.log guest user, like this. Now here we need to add the break statement. So we jump out of this switch block. Otherwise, the other statements here will be executed. Let me show you. So we need to add another case statement. If this user is a moderator, we want to display console.log moderator user. Once again, we need to add the break. So in this case, if I don't add this break statement here and the role equals guest, both these console.log statements will be executed. That's why we need to add a break to jump out of this switch block, right? Now, we can have as many case statements here. There is no limitation. Optionally, if none of these cases are matched, we can have a default statement and execute one or more statements. So console.log unknown user, or more accurately, unknown role. Now here for the default statement, we don't need a break because at this point, the control would automatically get out of this switch block, right? So let's save the changes and see what we get on the console. Save. We get unknown user because I have not initialized role, so its default value is undefined and it doesn't match any of these case statements. Now if I change this to guest, save the changes, we get guest user, and similarly if I change it to moderator, we'll get the moderator user message. So here's the takeaway. With switch and case, we can compare the value of a variable against a bunch of other values. Now, they don't have to be a string, they can be numbers or even booleans, but using booleans here is less common because if you want to compare the value of a variable with true or false, it makes more sense to use an if statement. Now, just to let you know, we can implement this exact logic using if and else statements. Let me show you. So if role equals guest, note that I'm using strict equality here, so triple equal signs, and that means we're checking the type and the value of this variable against what we have on the right side. So if role is guest, we want to do a console.log of guest or guest user. Else if role equals moderator, then we're going to do a console.log of moderator. Finally, else, if the role is something else, we want to display unknown user. Now compare these two implementations. You can see implementing this logic with if and else is cleaner and shorter. We don't have all these break statements or default or these curly braces. These are extra noise in the code. So it doesn't mean you should never use switch and case. Well, it depends who you ask. I personally tend to use if and else more often. Switch and case are kind of outdated. They look a little bit ugly in my personal opinion. But there's nothing terribly wrong with them. Sometimes they're more explicit. It comes back to your personal preference. Sometimes we want to repeat an action a number of times. For example, let's imagine we want to display hello world 5 times on the console. The poor way of doing that is like this. So console.log hello world, and then repeat it 5 times. This code is ugly. There is a better way to achieve the same result, and that's where we use loops. In JavaScript, we have various kinds of loops, and all these loops essentially do the same thing. They repeat an action a number of times. We have for loops, while loops, do while loops, for in loops, and for of loops. All these loops essentially do the same thing, but there is a subtle difference between how they start and end. Let's start by looking at the for loop. So back to this code. This is how we write a for loop. So for, we add parentheses. Now here we need 3 statements. The first statement is what we call the initial expression. And here we declare and initialize a variable. So we use let to declare a variable like I and set it to 0. Now I is short for index and is a common convention to use in for loops. This is what we call the loop variable. So we initialize it to 0, then we terminate this statement with a semicolon. Now the second part of the for loop is what we call a condition. So here we want to add a condition and compare the value of I with something else. This loop will run as long as this condition evaluates to true. So if we want this loop to run 5 times, we compare I with 5. So as long as I is less than 5, this loop will execute. You will see that in a second. Once again, we terminate this statement with a semicolon. And finally, the third part. This is what we call increment expression. And quite often, what we have here is something like this. So we use the increment operator to increment the value of I with 1. Now, after this for statement, we can add 1 or more statements, just like the if statements. If we have multiple statements here, we need to put them in a code block like this. Now here, we want to display hello world on the console. So our statement is console.log hello world. So instead of repeating this line 5 times, we put it in a for loop, and this loop will run 5 times. Now save the changes. So we get 5 hello world messages on the console. All right, now that you have seen a for loop in action, let's see exactly how this loop works. So earlier I told you this is what we call an initial expression. Here we're initializing I to 0. Now this loop will execute as long as this condition is true. So as long as I is less than 5, the statements we have here will be executed. Now, after the first iteration, I is incremented by 1. Then this condition is evaluated again. So 1 is less than 5. So one more time, this loop is executed. So we have the second iteration. Now after the second iteration, once again, I is incremented by 1. So now we are in the third iteration. Again, this condition is evaluated, and because it is true, the loop is executed. To show you this in action, I'm going to output I on the console. So save the changes. This is what we get. So note that in the first iteration, I is 0, then it's incremented by 1 until it reaches 4. So at the end of 5th iteration, I will be 4. And when we increment that by 1, it will be 5. So this condition will evaluate to false. So essentially, there are 2 ways to repeat an action a number of times using the for loop. Let's say we want to repeat something 5 times. We can initialize I to 0 and check to see if it's less than 5. Alternatively, we can initialize this to 1 and check to see if it's less than or equal to 5. Now, if we save the changes, you can see I starts from 1 and finishes at 5. Now, we can make this program a bit more interesting. Let's say we want to display the odd numbers between 1 to 5. So instead of logging hello world on the console, we can have an if statement and check the remainder of the division of I by 2. So if the remainder of division of I by 2 is not 0, that means I is an odd number. So we can display it on the console. Save the changes. So here are the odd numbers between 1 to 5. There is also another way to write this loop. Instead of starting from 1 and going all the way up to 5, we can start from 5 and go back to 1. So we change the initial expression, set I to 5. As long as I is greater than or equal to 1, now we want to decrement I. Save the changes. Now we get the odd numbers in the reverse order. Now it's more common to use the previous form, so we initialize I to 0 or 1 and increment it in every iteration. But in certain problems, you want to use a for loop in the reverse order. In the last lecture, we wrote this for loop to display all the odd numbers between 0 and 5. Now in this lecture, I'm going to show you how to implement the same logic but using a while loop. Now one key difference between a while loop and a for loop is that in for loops, the loop variable is part of the loop itself. But in while loops, we have to declare this variable externally. Let me show you what I mean. So we start with declaring a variable like I and set it to 0. Note that this I we have here is different from the I we have in this for loop because this variable is only meaningful and accessible inside of this for loop. This is called scope, and I'm going to talk about it later in the course. All I want you to know is that these two variables are completely different even though they're named the same. Now, we have our loop variable initialized to 0. Next, we add a while statement. In parentheses, we need to add our condition. What is the condition here? That is I less than or equal to 5. So I'm going to add that here. Next, we need to add our statements. So what is the statement that we want to repeat? Here's the statement. We want to display the odd numbers. So we add that here as well. And finally, at the end of this while block, we need to increment I. So this is a direct translation of this for loop into a while loop. So this is what happens when we execute this code. Initially, I is 0. Now, in the while loop, first, this condition is evaluated. If this condition is true, then the body of the while loop will be executed. Again, in the next iteration, the condition is evaluated again. If it's true, the statements in the while block will be executed. Otherwise, the while block will terminate. In the next lecture, we're going to look at another kind of loops in JavaScript. All right, now let's take a look at the third kind of loop we have in JavaScript. That is a do-while loop. Do-while loops are very similar to while loops, but they're slightly different. It's easier to show you in code. So I'm going to rewrite this logic using a do-while loop. Just like the while loops, we have to declare our loop variable externally. So we declare I and initialize it to 0. Okay, now if we save the changes, we're going to get an error. Identifier I has already been declared. Because I have declared I here, so I cannot redeclare it here. This is different from the I that we have in the for loop. Again, this is all about scoping, and I'm going to talk about that later in the course. So to make this work, I'm going to temporarily comment out these few lines and rewrite this logic using a do-while loop. So we add the do statement here, then a code block. In this block, we should have our statements. So I'm going to borrow them from our while loop, copy these, paste them here. And then finally, at the end of this block, we add the while statement along with our condition. That is I less than or equal to 5, followed by a semicolon. Now you might be wondering, what is the difference between a while loop and a do-while loop? Do-while loops are always executed at least once, even if this condition evaluates to false. Let me show you what I mean. So I'm going to temporarily comment out these few lines and bring back our while loop. Also, we don't need this for block for now, so let's comment it out. Now, if we save the changes, we get 135 on the console. However, if I change I to 9, we're not going to see anything. Because the first time we try to execute this while loop, this condition evaluates to false. So these statements are never executed. So save the changes. Look, there's nothing in the console. So in while loops, this condition is evaluated ahead of time. at the beginning of every iteration. In contrast, in do-while loops, this condition is evaluated at the end. And that means these statements are always executed at least once, even if the condition is false. So let's try this. I'm going to comment out this while loop and change I to 9, just like before. Save the changes. We get 9 on the console. Why? Because in our do while loop here, on line 15, we check to see if this is an odd number. It is, so we display it on the console. Next, we increment I by 1, so I is 10. Then the condition is evaluated. Of course, it's false, so our loop will terminate. Now, realistically, you're not going to use this do while a lot in programming. There are situations you may want to use this, but in practical terms, most of the time you'll be using a for or a while loop. Just be aware of the difference between the while loop and the do while loop. Writing loops, something that you need to be aware of is what we call an infinite loop. So an infinite loop, as the name implies, executes infinitely or forever. So if you accidentally create one of these loops, you're going to crash your browser or your computer. Let me show you an example. So here I'm going to declare a variable, set it to 0, put it in a while loop. So as long as I is less than 5, we're going to do a console.log of I. Now here technically we should increment I, but if we forget to do so, we end up creating an infinite loop. Because in the first iteration, I is 0 and it's less than 5, so we'll display I on the console. Now in the second iteration, I is still 0 and is less than 5. So this loop will run forever. Let me show you. So I'm going to save the changes. Now on the console, this number you see before 0 is the number of times we're displaying 0 on the console. So you can see this number is increasing rapidly. So far we have displayed 0 more than 3,500 times. And if you look at the browser, you can see this spinner going forever. So the only way to get rid of this is to close this window, or if this doesn't work, you'll have to force quit Chrome. So this is one example of an infinite loop. Here's another example. While true. Again, this loop is going to run forever, so it's an infinite loop. And by the way, infinite loops are not limited to while loops. We can create an infinite do while loop. So do while true. Or similar to the last example, maybe we'll create a loop variable like 0 and then have a condition like x is less than 5, but we forget to increment x here. We can also create an infinite for loop. So for let I equal to 0. As long as I is greater than 0, I plus plus. Again, with the condition that we have placed here, this loop is going to run forever. Or maybe we have the right condition, like I is less than 10, but we forget to add the third part. So we don't increment I. And this is exactly like this while loop that we had earlier, without incrementing I. So be aware of the infinite loops, avoid them, because they can crash your browser or your computer. You have learned about 3 kinds of loops in JavaScript: for loops, while loops, and do while loops. With all these loops, we can repeat an action a number of times. But we have 2 more kinds of loops in JavaScript, and we use them to iterate over the properties of an object or elements in an array. Let me show you. In this lecture, we're going to look at the for in loop. So let's say we have an object like person with 2 properties, name, mosh, and age 30. Let's say we want to display all the properties of this person object. That's when we use the for in loop. So for, now in parentheses, unlike the for loop that you learned about earlier, we don't have 3 parts. So we don't have that initial expression followed by semicolon, a condition, followed by the increment part. It looks a little bit different. Let me show you. So we have let key in person. So in every iteration, this key variable in the loop will hold the name of one of the properties in this person object. Let me show you. So here I'm going to do a simple console.log of key, save the changes. So in the first iteration, key is name, and in the second iteration, it is age. Now, what if you want to display the value of each property next to it? Well, earlier I told you that there are two ways to access the properties of an object. We can use the dot notation, which looks like this, person.name, or we can use the bracket notation. So person, square brackets, the name of the target property as a string. Earlier I told you that we use the bracket notation when we don't know ahead of time, at the time of writing code, what property we're going to access. Perhaps the name of the target property is calculated at runtime. Here is a real example. When we iterate over the properties of the person object, in each iteration, the value of key is going to be different. So here we can use the dot notation to display the value of this property. In other words, we can do something like this. Because we don't have a property called key in the person object. So that's when we use the bracket notation. So we add square brackets and pass key as the name of the target property. Now let me delete this stuff here, save the changes. So you can see the value of name is Mosh and the value of age is 30. So this is the for in loop, and we use it to iterate over the properties of an object. We can also use this to iterate over an array, but it's not an ideal way. In the next lecture, I'm going to show you a better way, but let's see how that works before we finish this lecture. So I'm going to define an array called colors with 3 values, red, green, and blue. Now we can use the for in loop to iterate over this array. So for let index in colors, note that I named this loop variable index because in each iteration, this index variable will be set to the index of one of the elements in this array. So it's going to be 0, 1, and 2. Let's take a look. So console.log index. Save the changes. So we get 0, 1, and 2. Now, if you want to get the element at the given index, once again, we use the square bracket notation. So, comma, colors of index. Save the changes. And now we can see each element in our colors array. Now, starting from ECMAScript 6 or ES6, which is the modern version of JavaScript, we have a new kind of loop that is called for of loop. And that is an ideal way to iterate over arrays. And that's what you're going to learn in the next lecture. So as I told you in the last lecture, starting from ECMAScript 6 or ES6, we have a new way to iterate over arrays. And that is using the for of loop. It's very similar to the for in loop, but instead of the in keyword, we use the of keyword. So here's an example. For let color of colors, we can simply log this color on the console. You can see with this new for loop, we don't have to deal with this index, and we don't have to access the element at the given index. So in each iteration, this color, which is our loop variable, will hold one of the items in this array. So when I save the changes, we see red, green, and blue. So I'm going to delete this for in loop, bring the colors array down to summarize everything. So we use the for in loop to iterate over the properties of an object, and the for of loop to iterate over the elements or items in an array. With all the loops you have learned about in this section, there are 2 keywords, break and continue, that can change how the loop behaves. In this demo, I'm going to use a while loop, but what you're going to learn applies to all kinds of loops you have learned in this section. So let's start by declaring a variable called I and initialize it to 0. Now we put this in a while loop. As long as I is less than or equal to 10, we want to display I on the console and then increment it. Save the changes. So this gives us numbers 0 to 10. Now sometimes you want to jump out of a loop for some reason that may happen at runtime. For example, here we can have an if condition, an if statement with a condition like this. If I equals 5, we want to jump out of this loop. That's where we use the break keyword. Now when we save the changes, see what happens? We get the numbers 0 to 4. So at the end of the 5th iteration here, we increment I. Now I is 5, so we break out of the loop. Now let me comment this out and look at the continue keyword. So I'm going to write another if statement. I want to see if I is an even number or not. So I modulus 2 equals 0. If that's the case, I want to increment I and then continue. Let's see what happens when we run this code. Save the changes. We only get the odd numbers. Why is that? All right, let's take a look at an example. So when I becomes 2, it's an even number. At this point, we increment I, so I will be 3. Now, when the JavaScript engine sees the continue keyword, it will jump to the beginning of the loop and continues execution of the next iteration. At this point, I is 3, so this if statement is not executed, and that's why we see I on the console. Now, in my personal experience, continue is not something that you would use that often. It's one of those old legacy things in the JavaScript language. I'm only explaining it here in case you see it in projects that you're working on. But it's not something that I recommend you to use. It's an ugly way of writing code. So just to recap, with the break keyword, we jump out of a loop, and with the continue keyword, we jump to the next iteration. All right, here's an exercise for you. I want you to write a function that takes two numbers and returns the maximum of the two. Call that function, give it different arguments, and make sure it's working properly. So pause the video, do this exercise, and when you're done, come back, continue watching. I'm going to start by defining a function, call it max. Here we need two parameters. We can call them number 1 and number 2, or we can use shorter names like A and B. Now earlier I told you not to use mysterious variable names like A and B. But in this particular case, it doesn't really matter because A and B are kind of self-explanatory. So we're not dealing with a complex logic. We don't have to guess what A and B are, as you will see in a second. So in this function, we want to have some logic. We want to compare the value of A with B. So we're going to use an if statement. So if A is greater than B, we want to return A. Else, we want to return B. That's the simplest implementation. It's not the best way. We're going to optimize this step by step. But before going any further, let's make sure that this function actually works. So I'm going to declare a variable called number and set it to max of 1 and 2. Now let's display number on the console. Save the changes. So max is 2. So if the second argument is greater, our function works. What if the first argument is greater? So let's change 1 to 3. Save. Now we see 3. Perfect. What if both arguments are equal? Once again, save the changes. We still see 3. Perfect. Now, before going any further, did you notice how I called this function with different arguments? I called it with different test cases. First, I assumed if the second argument is greater, then I assumed if the first argument is greater, and finally I assumed that both arguments are equal. So when writing code, when writing functions, you should test your functions with different possible values, okay? Now, let's get back to this max function and clean up this code. The first thing I want to improve here is to remove this else keyword. Why? Because if A is greater than B, we're going to return A, so we'll jump out of this function. So none of the code after line 6 will be executed. In fact, we will never get to this point. So we don't really need the else keyword, okay? So if A is greater than B, we'll return A, otherwise we'll return B. So this is a cleaner implementation. But hey, we can make this even cleaner. So earlier you learned about the conditional operator. Remember this? So we had a condition in parentheses, question mark, If this condition evaluates to true, we use one value, otherwise we use the other value, right? We can rewrite these two lines using our conditional operator. So what is the condition here? If A is greater than B. If this condition is true, we want to return A, otherwise we want to return B. All we need here is a return statement and terminate this with a semicolon. So this line is exactly equivalent to these two lines. Now, save the changes. Both arguments are equal. We get 3, so far so good. Let's try another test case. I'm going to make the first argument larger. Let's say 5. We get 5. Now let's make the second argument larger, 10. Beautiful. So our function is working. Here is another exercise. I want you to implement this function. Function is landscape. It takes two parameters, width and height of an image, and returns true if the image is landscape, which means width is greater than height. Otherwise, it returns false. Now, you may think this is similar to the exercise from the last lecture. In fact, it is, but I want you to do this exercise because I'm going to give you a simple and effective tip to write better code. So pause the video, do the exercise, and then come back, continue watching. All right, so similar to the last lecture, we can start with a simple if and else. So if width is greater than height, we want to return true. Otherwise, we want to return false. But I told you that in this case, we can use the conditional operator. So we add the condition. If width is greater than height, we can return true. Otherwise, we'll return false. And here's our return statement, right? So here's the implementation of this function. However, code like this looks very amateurish. You don't want to return true or false explicitly. This is very ugly. Why? Well, let me show you. We can completely delete this part here and simply return the value of this expression. So if width is greater than height, this expression will be evaluated to true. So we'll simply return true. Otherwise, if width is less than height, this expression will evaluate to false, so we'll return false. So there is really no need to explicitly return true and false here. That's a poor way of writing code. So now we have this function. Let's test it. We can do a console.log. Simply call this function here is landscape. I'm going to pass these dimensions 800 by 600. So we expect true on the console. Save the changes. Here's true. Beautiful. Now let's change the width to, let's say, 300. Now we have a vertical image. Save. So we get false. Next exercise I want you to work on is a very popular interview question called the fizz-buzz algorithm. So we have this function called fizz-buzz. We give it an input and it returns a string. Let me show you how that works. So let's declare a constant called output. Here we call fizz-buzz and pass an input like 3. Then log the output on the console. Let's see what we get. We get fizz. So if the number that we pass in is divisible by 3, we get fizz. So let me show you here. If the number is divisible by 3, we get fizz. Now, if the number that we pass is divisible by 5, we get buzz. So divisible by 5, we get buzz. Now, if the number that we pass in is divisible by 3 and 5, like 15, we get fizz buzz. So divisible by both 3 and 5, we get fizz buzz. Now, if the number is not divisible by either 3 or 5, we're going to get the same number. So if we pass, let's say 7, we get 7. So not divisible by 3 or 5, we get the same input. Now, if we don't pass a number here, let's say we passed a string, we should get this message, not a number. The same is true if we pass a Boolean or anything that is not a number. So if the input is not a number, that is the message that we should display on the console. So I want you to pause the video, spend 10 to 15 minutes on this exercise, and when you're done, come back, continue watching. All right, let's see how we can implement this fizzbuzz function. So we get the input. First, we want to see if this is a number or not. Because if it's not a number, then we don't care about dividing that number by 3 or 5. So for that, we use the type of operator. So if type of input is not number, we want to return this message, not a number. So that's the first if statement in this function. Now, if we get to this point, that means we have a number. We want to see if this number is divisible by 3, 5, both of them, or none of them. We can write an if statement like this. If input modulus 3 equals 3, that means this number is divisible by 3. So we return fizz. Similarly, we're going to have another if statement. So if input modulus 5 equals 0, we're going to return buzz. Next, we want to see if this number is divisible by both 3 and 5. So if input is divisible by 3 and input is divisible by 5 as well. Now here we're dealing with a complex expression. To make this code more readable, I would like to put each expression in parentheses, like this. So here we have one expression, then we have the logical and the second expression. We can select this expression and type the opening parentheses, and this automatically adds the closing parentheses. That's a quick tip for you. So if this number is divisible by both 3 and 5, we want to return fizzbuzz. And if we get to this point, that means that number is not divisible by either 3 or 5. So we simply return the same input. Now let's test this function. So initially I've passed false. We should get not a number on the console. Save the changes. We get not a number. Beautiful. What happens if we pass 3? We get 3. What happens if we pass 5? We get buzz. So far, so good. What if we pass 15? 15 is divisible by both 3 and 5, so we should get fizzbuzz. Save the changes. Wait a sec, what happened here? We got fizz, whereas we expected fizzbuzz. The reason for that is because of how we have ordered our if statements. So in this case, 15 is divisible by 3, so this if statement is executed, and here we immediately return fizz. To solve this problem, we need to move this if statement on the top. So I've selected these two lines. Now to move this code up, we can simply press the Alt key and the up arrow. As simple as that. Okay, so if the number is divisible by both 3 and 5, we immediately return fizzbuzz. Now, let's save the changes. Okay, the problem is solved. What if we pass a number that is not divisible by 3 or 5? Let's say 7. Now we get the same input. Beautiful. So this is the fizzbuzz algorithm that you see in a lot of programming interviews. Now I want to show you something. In JavaScript, we have this special value called not a number. So here I'm going to replace this string with not a number. Whenever you're dealing with some mathematical calculation, if the result is not a number, this value is returned. So we can use the same value instead of returning a string like not a number. Now, this was not part of the exercise. It's something that I'm teaching you now. So let's save the changes. Now, instead of passing a number, let's pass false. Now we get not a number. Let's take a look at the type of this value. So type of not a number. Weirdly enough, the type of this value is a number, but the value is something specific that is not a valid mathematical number. But this exercise is a little bit more complicated than the earlier exercises. So I want you to implement this function, check speed, This function takes a parameter that's the speed of a car. Now in this program, I'm assuming that speed limit is 70 kilometers an hour. So if a car is driving under the speed limit, we get this OK message on the console. Similarly, if we pass 70 here, so if somebody is driving exactly at the speed limit, they're still good. We still get the OK message. Now for every 5 kilometers above the speed limit, they're going to get 1 point. So if I drive at 75 kilometers an hour, I get 1 point here. But what if I drive at 72 kilometers an hour? I'm still good. So for every 5 kilometers above the speed limit, we should give the driver 1 point. Now, as part of calculating the point here, you will have to use one of the built-in functions in JavaScript. That is math.floor. We can give this function a floating point number, like 1.3. Let's say 1.3 points. And this will convert that to the greatest integer. For example, if we go in the console here and type math.floor of 1.3, we get 1. So you will have to use this function as part of your calculations, okay? Here is a tip for you. Now back to our check speed function. What if we pass 80 here? We should get 2 points, right? So we get 2 points, beautiful. Now what if we drive at 180 kilometers an hour? Our license is suspended. So if a driver gets more than 12 points, then their license should be suspended. So here's the logic for this function. I want you to spend 15 to 20 minutes to do this exercise. Once you're done, come back, continue watching. All right, now let's see how I solve this problem. So let's define a function called check speed. It takes this speed parameter. Now first we want to see if the speed is less than the speed limit. So here's a simple if condition. If speed is less than 70 kilometers an hour. We want to display console.log. Okay. Now the first thing I want to improve here is to turn this magic number into a constant, because someone else looking at this code may not know what 70 represents here. So you should avoid using magic numbers in your code. Always use constants to describe them. So here we can define a constant. Speed limit, we set it to 70, and then replace this magic number with speed limit. With this change, now our code is more expressive, and also, if you want to use this number somewhere else in this function, we don't have to repeat it multiple times. We have defined it here once, and we can reuse it in multiple places. If tomorrow the speed limit changes to, let's say 75 or 65, there is only a single place that we have to change, okay? So if the speed is less than the speed limit, we display OK. Otherwise, we should calculate the points. So here we need a simple calculation. We want to get the speed, subtract it from the speed limit, and then divide the result by 5. Because for every 5 kilometers above the speed limit, we should give them 1 point. Now, once again, we don't want to use this magic number here. It's not descriptive. So we want to turn this into a constant. So let's define another constant. We can call this kilometer per point and set it to 5. And then replace this magic number with km per point. So with this, we get the number of points that we should give to this driver. Now, the result of this expression can be a floating point number. So earlier I told you to use math.floor to convert that floating point number to the greatest integer. So here, we can call math.floor, and as an argument, we pass this expression here. So this is how we calculate the points. Now we should check to see if the driver gets more than 12 points. So we need another if statement. If points is greater than or equal to 12, we want to suspend their license. So console.log license suspended. Otherwise, we want to display the number of points on the console. So console.log points. And as a second argument, we pass this points variable. Now, technically here, I could also use a constant, and that's a better practice to make sure I don't accidentally modify these points here. So we change this to a constant. And if we accidentally try to modify points like this, we're going to get an error. Okay? So as I told you before, const or constant should be your default choice. If you want to reassign a variable, that's when you use the let keyword. Now let's test this program up to this point. So on the top, I'm going to call this function check speed and pass 50. Save the changes. We get OK. So far, so good. What if we drive exactly at the speed limit? That's weird. Instead of getting 0 points, we should get the OK message. So there is a bug in our condition here. So if speed is less than or equal to speed limit, we should get the OK message. Save the changes. Now the bug is solved. What if we drive 1 kilometer above the speed limit? Notice all the test cases I'm going through for this exercise. It's very important that when you write a function, test it with different values. So if we call this function with 71, what should we get here? We should still get the OK message instead of 0 points, because starting from 75, we should get the first point. So let's save the changes and see what we get. We got 0 points. So we still have a bug in this function. Well, we should actually change this condition to something like this. So we want to get the speed limit, in this case 70, at kilometer per point. So that would give us 75. If we drive less than 75, we're still good. But from 75 kilometers an hour or faster, we should get a point. So let's save the changes. At 71 kilometers an hour, we get the OK message. Beautiful. What if we drive at 75? We should get 1 point. So here's 1 point. What if we drive at 70, let's say 7 kilometers an hour? We should still get 1 point. So save the changes, 1 point, beautiful. What if we pass 80 here? We should get 2 points. There you go. Now to get 12 points, we have to drive 12 times 5, which is 60 kilometers above the speed limit. So if we pass 130 here, we should get 12 points and our license should be suspended. Save, license suspended. Beautiful. So our function is working. I just want to show you one more tip to make this code cleaner. So here we have this else block, and this has caused indentation here. Now, this is not a terribly bad thing, but it's better to avoid indentation if we can, because otherwise we have to scroll to the left and right to see what's happening here, right? So if this condition is true, we want to display OK on the console. Now, to get rid of this else block and the indentation, we can add a block here, display OK on the console, and then return. So with this, we'll jump out of this function and none of the code here will be executed. So with this, we can delete this else statement as well as the code block and remove the indentation. All right, here's your next exercise. I want you to write a function called showNumbers that takes a parameter called limit. So we pass a number here like 10, and when we call this function, we should see all the numbers from 0 to the number we supplied as the limit. Now next to each number, if that number is even, you should display the even label, otherwise you should display odd. It's a fairly easy exercise. Pause the video, spend a few minutes, and when you're done, come back, continue watching. So here we need a for loop. We set our I variable to 0. And as long as I is less than or equal to this limit, we're going to run this loop. And in every iteration, we'll increment I. Now here we need to check if I is an even number or not. So if I modulus 2 equals 0, we display console.log of I. And as the second argument we pass even. Otherwise, we do a console.log of I and odd. Now there is another way to write this program. So instead of having two separate console.log statements, we can do something like this. We can declare a constant, call it message. And here we can use the conditional operator. So if I is an even number, we set message to even, otherwise we set that to odd. Next, we do a console.log of I and message. I find this second implementation cleaner and less noisy, but if you use the first implementation, that's perfectly fine as well. Now, save the changes. We get all the numbers from 0 to 10. In this exercise, I want you to create a function called countTrueC, which takes an array and returns the number of trueC elements in this array. Now, what are these trueC or falsy values? Let me quickly refresh your memory. Sometimes when we have an if statement, we might pass a Boolean true or false as the condition here. For example, we might have a constant called isActive. We set this to true. And when we use this constant as the condition here, we get this hello message on the console because this is a Boolean true. But sometimes what we have in our if statement is not necessarily a Boolean value. It could be a string, it could be a number, it could be an object. So the JavaScript engine tries to convert that value to something that is like a Boolean, but it's not a Boolean. Here's an example. Let's say I have a constant called name. I set this to this string, mosh. Now, if I pass name here, obviously name is a string. It's not a Boolean true or false. So the JavaScript engine tries to interpret this as trueC or falsy. So when we run this code, you can see we still see the hello message because we're dealing with a string of characters. So this is what we call a trueC value. It's not the Boolean true, it's trueC. In contrast, if we had an empty string, JavaScript engine would see this as falsy. Again, it's not the Boolean false, it's falsy. Now, when we run this code, we no longer see the hello message. So that's all about trueC and falsy values. Now let's quickly review the list of falsy values in JavaScript. So undefined, null, empty string, the Boolean false, 0, and not a number. You learned about this value in an earlier exercise. That's something that I forgot to mention when I talked about all the falsy values in JavaScript, but this is the complete list of falsy values in JavaScript. So now your job is to create a function called countTrueC that gets an array and returns the number of trueC values in this array. So here's an example. If I declare this array and set it to 1, 2, 3, so here we have 3 trueC values. We call countTrueC, pass this array, and immediately pass the result to console.log. Now save the changes, so we get 3 here. Now if we add 0 here, because 0 is a falsy value, we still get 3. If we add null, undefined, and empty string, we still get 3. If I remove one of these numbers, let's say 1, we get 2. So go ahead, do this exercise, and when you're done, come back, continue watching. All right, to count the number of trueC values, first I'm going to declare a variable called count and initialize it to 0. Now we need to use a for-of loop to iterate this array. And for each element, we need to check to see if that element is trueC or not. If it's trueC, we're going to increment count. So for let value of array. Now, if this value is trueC, we simply increment count. And finally, we return this count. That's all the code you had to write. So note that here, I'm not comparing this value with all those falsy values. In other words, I didn't write code like this. If value is not false or value is not undefined, this is a very poor way of writing this code. We don't want to have 5 conditions here for every falsy value. We simply pass that value here. Now that value might be a Boolean or a non-Boolean. If it's not a Boolean, the JavaScript engine tries to interpret it as truthy or falsy. So if the result is truthy, then count will be incremented. As simple as that. All right, here's another simple but great exercise. Your job is to create a function called showProperties. We pass an object here, and this function should display all the properties of this object that are of type string. Let me give you an example. So on the top, I'm gonna define an object like movie. We use the object literal syntax to initialize this. So here we're gonna add a few properties like title. We set it to a simple string. The value doesn't really matter. A is enough. Release year, we set it to a number like 2018. Rating, again, a number. And then director, we set it to another string. Now, if we call this function showProperties and pass this movie object, see what we get. We see the string properties of our movie object. So title is A and director is B. So pause the video, do the exercise, and when you're done, come back, continue watching. All right, here we need to use the for in loop to iterate over the properties of this object. So for let key in object. So in each iteration, this key will hold the name of one of these properties. Let's have a quick look here, console.log of key. So we get title, release year, and so on. Now we need to get the value of each of these properties and then check the type of that value. If the type is a string, then we'll display the property and its value. So to get the value of this property, we use the bracket notation. So object of key. Now to check the type of this value, we use the type of operator, and then we put this in a if statement. So if the type of object of key equals string, then we simply display the key as well as object of key. Save the changes. We only get the title and director properties. That's something I need to emphasize here. You might be wondering why I didn't use curly braces here, because we have 2 lines under this for statement. Well, accurately, we have only a single statement under this for statement. So this console.log is a single statement that belongs to our if statement. So here we don't really need curly braces because we're dealing with a single statement under the for statement. But if you prefer to put the curly braces here, that's perfectly fine. So let me show you. It looks like this. It's more of a personal preference. Here's another simple but great exercise that trains your programming brain. So I want you to create this function called sum. We give it a limit, and this function will return the sum of all the multiples of 3 and 5 from 0 up to this limit. Here's an example. What are the multiples of 3 and 5 between 0 and 10? Well, multiples of 3 are 3, 6, and 9. And multiples of 5 are 5 and 10. So I'm including this number that is passed as a limit. Now, if we add these numbers together, the result will be 33. And that's the job of this function. So save the changes, we get 33. Here we need to start with a for loop. So for let I equal to 0, as long as I is less than or equal to limit, we want to increment I. Now we need to check to see if I is a multiple of 3 or 5. So if I modulus 3 equals 0, or I modulus 5 equals 0, now we need to take I and add it to our sum. So here we need to declare a variable, sum, set it to 0. And if I is a multiple of 3 or 5, we need to add I to sum. And finally, we return sum. Now pay attention to how I have formatted this code. I have added these extra vertical line breaks to separate the initialization from the actual logic from the return value. If we didn't have these vertical breaks, this code would look a little bit squashed. It's a little bit hard to read. So as a best practice, it's always good to separate the last line, the return statement. Now in this case, we can have all these lines together because they're highly related. So we start with initializing sum to 0, and now we're still working on sum to add something to it. However, some developers prefer to separate the initialization, so you could add a line break here as well. That's more of a personal preference. But what I want you to take away is that lines that are highly related should be together, and they should be separate from other lines. In this exercise, we want to calculate the grade of a student. So here are the marks of a student in different subjects. We pass this array to this function, calculate grade. What this function does is first it calculates the average grade. So what is the average here? 80 plus 80 plus 50, that comes to 210 divided by 3, so the average is 70. Now here we need a table to see what grade this average corresponds to. So if the average comes down to this range 1 to 59, the grade should be F. If it is between 60 and 69, that should be D. If it's between 70 and 79, that should be a C. If it's between 80 and 89, that should be a B. And finally, if it's between 90 and 100, that should be an A. So spend 5 to 10 minutes on this exercise. When you're done, come back, continue watching. All right, here first we need to calculate the average mark. So to calculate the average, first we need to declare a variable like sum, initialize it to 0. Then we need to use the for loop to iterate this array of marks and calculate the sum of all these marks. So for let mark of marks, we get mark and add it to sum. So sum plus equals mark. So this is the total. Now to get the average, we need to divide sum by the number of marks, that is marks.length. Now we have the average. We need to use this table to map it to a grade. So one way to calculate the grade is like this. So if average is greater than or equal to 0, actually here the range should be 0 to 59. So if average is greater than or equal to 0 and average is less than or equal to 59, we're going to return F. And similarly, we can have a few other if statements for other grades, but this code is a little bit ugly. There is so much noise in this code. Instead of having two conditions along with the logical AND, we can simplify this expression to something like this. If average is less than 60, because the range for F is 0 to 59. So as long as average is less than 60, we get the same result. See what I did here? So there are different solutions to solve a programming problem, and you should aim for the simplest solution, because as Leonardo da Vinci says, simplicity is the ultimate sophistication. So using this pattern, I'm going to calculate the other grades. So if average is less than 70, return D. Because if we get to this point, that means average is at least 60 or higher. Now I'm just checking the upper limit. So the upper limit should be 69. So if the average is between 60 and 69, we return D. Similarly, if the average is less than 80, we'll return C. If average is less than 90, we'll return B. And if we get to this point, that means the average is at least 90 or greater. We don't really need another if statement here. We can simply return A. Now we can make this code even better. While this function is fairly simple, it's only about, I don't know, maybe 10 lines of code. We can break this function into two smaller functions, each focusing on one thing. That is what we call single responsibility principle. I use a metaphor. Think of a restaurant. People working in a restaurant have different roles. So the chef is in the kitchen, responsible for cooking. The chef doesn't come out and take orders. So he or she is responsible only for one thing. The same goes for the manager. The manager is responsible only for one thing, managing the restaurant at a high level. We have the same concept in programming. So we should have functions that are small and are focused only on one thing. In this function, we are basically doing two different things. The first part of this function is all about calculating the average of numbers in an array. And the second part is about mapping that average to a grade. So we can extract these few lines, put them in a separate function like this. So function, calculate average. We give it an array. This array can be anything. It can be an array of marks, or it can be an array of temperatures, anything. We can reuse this function in the future whenever we need to calculate the average of a bunch of numbers. Now, I'm going to get all this code, cut it, put it here. Now here we need to rename a couple of variables. Here we're working with marks, but the parameter of this function is called array. So put the cursor here, press F2 and rename this to array. Also, we need to rename our loop variable from mark to value. So now we have a generic function. It's not tied to marks. It can be reused in different situations. And finally, we can return the average here, or we can make this code even simpler. So instead of storing the average in a variable and then returning it, we can simply return the result of this expression. So return sum divided by array.length. See? And finally, we can reuse this function here. So we declare a constant, average, and set it to calculate average of marks. With this change, now we have two very simple functions. Each function is responsible only for one thing. This exercise is a very popular exercise for junior programmers. So we have this function, show stars, with a parameter called rows. So when we call this function and pass 5, see what we get on the console. We get 5 rows. In each row, we have a star, and the number of stars in that row depends on the row we are in. So in the first row, we have 1 star. In the second row, we have 2 stars, and so on. If we call this function, pass 1, we get only a single star. If we pass 2, we get 2 rows. If we pass 10, you got the point. So go ahead and spend 5 to 10 minutes on this exercise. When you're done, come back, continue watching. All right, here we need to start with a for loop. So for let row, we set this to 1. As long as row is less than or equal to the number of rows, we want to increment row. Now in each row, depending on the number of row, we need to display 1 or more stars. So here I'm going to declare a variable. Let's call it pattern. We set it to an empty string. Now, depending on the value of the row, we need to add 1 or more stars to this pattern. So here we need another for loop for let. Let's call this I. We set it to 0. As long as I is less than row, we increment I. And here we add a star to the pattern. So plus equals star. So if you're on row 5, this loop will execute 5 times because we started from 0, and we run this while I is less than row. So this will execute 5 times, and each time we'll append 1 star to our empty string. So we'll end up with 5 stars. And finally, when we're done with this loop, we do a console.log of pattern. That's all we have to do. Now on the top, I'm going to change this to 5, save the changes. The algorithm works beautiful. If we pass 1, we get 1 star. If we pass 2, we get 2 stars. So what we have here is what we call a nested loop. So we have a loop inside of another loop. And you may see this pattern in a lot of algorithms. Last exercise for this section. I want you to create this function, show primes, that takes a limit and shows all the prime numbers up to this limit. So here are the prime numbers that we have up to 20. We got 2, 3, 5, 7, and so on. In case you don't know what's a prime number, let me give you a brief explanation. So in mathematics, numbers can be prime or composite. A prime number is one whose factors are only 1 and itself. So it cannot be divided evenly into another number. Let me give you an example. Think of 12. What are the factors of 12? Well, we got 1, 2, 3, 4, 6, and 12. These are the factors of 12. So when we divide 12 by these numbers, we won't get any remainder. The remainder will be 0. So we say 12 can be divided evenly by its factors. Now 12 is a composite number because it has many factors. A prime number, in contrast, has only 2 factors. It's 1 and itself. Here's an example. So we got 11 here. The factors of 11 are 1 and 11 itself. The same is true for 13. It can only be divided evenly by 1 and 13. So go ahead and create this function. You will see my solution next. To implement this function, we need a for loop that starts from 2 up to this limit, because the first prime number is 2. So for let I, we set it to 2, as long as I is less than or equal to limit I plus plus. Now for each number, we need to check to see if this number is prime or not. So we need another loop here that starts from 2 all the way to the current number, that is I. With this nested loop, we can see if I has a factor other than 1 and itself. So let's define another for loop. Now what should we call this other loop variable? We cannot call this I because we have already defined I here. So one way is to call this J, but someone reading this code, they don't know what is I, what is J. It's confusing. So always pay great attention to the name of your variables. What I is essentially representing here is a number. So the outer loop is for iterating numbers from 2 to this limit. So let's call I number. We press F2 here and rename it to number. Now what is this inner loop for? That is for finding the factors of that number. So instead of calling the loop variable J, we can call it factor. So factor, we set it to 2. As long as factor is less than this number, we want to do factor plus plus. Let me expand this a little bit so you can see. All right, now, if this number can be evenly divided by its factor, so if number modulus factor equals 0, that means this number has a factor other than 1 and itself. That's why I have not included 1 in this loop, because of course, every number can be divided by 1. For the same reason, I have not included the number itself in this loop, because again, we know that each number can be divided by itself evenly. So in this inner loop, we want to see if we have a factor other than 1 and the number itself. So if we do, that means this number is not a prime number. So basically what we can do here is declare a variable, call it isPrime. We can assume that this number is a prime number, but if this condition is true, then we need to set isPrime to false. Also, if we get to this point, there is really no need to continue this loop, because let's imagine we want to display all the prime numbers from 1 to billion. Now in this inner loop, as long as we find a factor for this number, that means this number is not a prime number. So there's really no need to continue running this loop, because this is just wasting our computer's processing power. So here we can add a code block, put isPrime here. If we get to this point, we can use the break keyword to jump out of this loop. Okay? Now, when we get to this point, isPrime is either true or false. If it is true, we log this number on the console. Save the changes. We get this result, beautiful. If we pass 10 here, we get all the prime numbers from 2 to 10. Now here's another challenge for you. Earlier I told you about the single responsibility principle. We want to have small functions, each function responsible for a single task. So I want you to modify this code, extract a new function, make sure each function is small and responsible for a single task. So pause the video. When you're done, come back, continue watching. So if you look at the lines 7 to 11, all we are doing here is checking to see if a number is prime or not. This logic does not necessarily have to be part of our show primes function. We can have a separate function called isPrime that takes a number and simply tells us if this number is prime or not. Then we can use this function inside of show primes function or somewhere else. So it's a reusable function. It's a reusable piece of code. So I'm going to extract all these lines, move them to our new function. Now we can make this code cleaner and more elegant. So if we get to this point, instead of breaking from the loop, we can simply return false. In other words, there is no need to break and then return isPrime. We can do a shortcut here. So if we get to this point, we simply return false. That means we don't need to set isPrime to false. We don't even need to declare isPrime. So we run this loop. We try to find a factor for this number. If we find a factor, we immediately return false. Otherwise, if we get to this point, that means we didn't find any factors for this number, so we return true. Also, we can get rid of all these curly braces because our for statement, our for loop has a single statement, and our if statement also has a single statement. So let's get rid of all these extra curly braces getting in the way, annoying me. Okay, that is better. Now finally, in show primes, so here we have only a single loop. We are iterating the numbers from 2 to this limit. We simply call isPrime function and pass our number. If the number is prime, we log it on the console. This also means we don't need these curly braces. And here's the end result. With these changes, now we have two very simple functions. If you give this function to the dumbest person in the world, they won't understand it. Also, we don't have nested loops. Generally speaking, nested loops are a bit hard to understand. So whenever you have a nested loop, that's probably an indication that you can extract the logic in the inner loop and put it somewhere else in a different function. So that brings us to the end of this section. I hope you enjoyed the materials and thank you for watching.